Okay, so we're going to look at some more examples of hypothesis testing for two independent means, or two independent samples focused on means instead of proportions. Okay, so when the background music was slow, the mean amount of bar purchases from a sample of 17 restaurant patrons was $30.47 with a standard deviation of $15.10. When the music was fast, the mean was 2162 with a standard deviation of 950, and that came from 14 restaurant patrons. Level of significance is 0.01, so 99% confidence. And is the true population mean higher when the music is slow? So notice if I'm leaving it in this order, music is slow first. Slow should be greater than fast. Okay, so the data from slow should be greater than fast. So if I keep it in this order, I have a greater than problem. Notice we're wondering if mean purchases with slow music is greater than purchases with fast music. So as long as I put slow first, I'm going to have a greater than in my claim. Okay, so this is a greater than problem in terms of what I put in Megastat. The null is basically the complement to it, the less than or equal to, but I could also just put the equal sign. Okay, so yes or no. I'm trying to figure out, is the true population mean higher when the music is slow? So slow greater than fast. And basically, if I can reject the null, I will say, yes, I did find evidence that the mean is higher with the music slow. If I don't find any evidence, then basically I'm going with the null, and I would say no here. Okay, so I enter the data like I've done before, the summary input, because I have the means and standard deviations and sample sizes, not the whole raw data set. Okay, comparing two independent groups again. And this is averages, not proportions. Okay, so I'm expecting slow to be greater than fast. Expect people to spend more when the music is slow than fast. That's what I'm testing. Always choose unequal variance. 99% confidence because the level of significance was 0.01. And always put hypothesized difference of 0. Okay, so my p-value is 0.0286, which is not less than 0.01. So I failed to reject the null. Basically, I have to go with the null, and I didn't find significance for the claim. There's no evidence that patrons spend more when there is slow music, so the answer to that question is no. However, again, we could change our confidence level to 95%, and that means the alpha becomes 0.05, and 0.0286 is less than 0.05. So at the 95% level of confidence, 5% level of significance, I can reject the null and support the claim that what people spend with slow music is greater than what they spend with fast music. Okay, so at 95% confidence, I do have evidence that patrons spend more with slow music. Okay, let's look at another problem. Random samples of Tuesday and Friday withdrawals from a college campus ATM were compared. We want to know if there's a difference in the means. So again, notice the wording. See if there's a difference in the means. Is there a difference? It's not claiming that Friday is more than Tuesday or that Tuesday is more than Friday. It's just wanting to know if there's a difference. So the claim or the alternate hypothesis is the not equal to sign. And as always, the null has the equal sign. If I can reject the null, then there is a difference. So I would say yes. If I can't reject the null, then I'm going with the null that basically they're equal, not statistically significantly different. And notice also here, these are 3 data points. It's not the mean, standard deviation, and sample size. They're actually just 3 data points for Friday, 3 data points for Tuesday. So I'm actually going to use the data input instead of summary input. And unfortunately, it's only sample sizes of 3. Okay, so I can choose data input this time and put Tuesday's values and then Friday's values. Since it's just a find the significant difference, find if there is a significant difference problem, I'm just going to choose the not equal to for the alternate hypothesis. Enter the data, unequal variance, 95% confidence is the default. Okay. Okay, p-value is 0.1393. Notice the sample sizes are only 3, and it's a two-tailed problem, or not equal to in the claim. P-value is 0.14. That is not less than any of the common values for level of significance. So sometimes you don't really need a level of significance. It's not going to be used to help you find your p-value. It's just used to compare at the end. So typically p-value is either so low or so high that you almost don't even need a level of significance, because it's either going to be less than all 3 of them or greater than all 3 of them. So I fail to reject the null, and I go with the fact that there is no difference between the amount withdrawn on Tuesday and the amount withdrawn on Friday. Not enough evidence to suggest that withdrawals are different from Tuesday and Friday. One reason could be those small sample sizes. Only 3, sample size of only 3 is not going to tend to lead to a significant difference unless it's a huge difference. Okay, let's look at another problem. Consider the same hospital from the Formula 1 problem. In addition to tracking handoff errors, the hospital also tracks handoff time. Okay, so remember, handoff errors was a proportion problem because it was number of errors out of a total. And now we're talking about means. We're not doing proportion problems anymore. So now we're going to be talking about average time. In these same samples, the average handoff time before changes was 23 minutes, standard deviation of 5. After the changes, average of 15 minutes, standard deviation of 8 minutes. So another indication that this is a mean problem rather than a proportion problem, because I've got the average, the word average there, and the standard deviation. You typically wouldn't have a standard deviation in a proportion problem. I've also got the before and after terminology, so that tells me this is a 2-sample hypothesis test problem or chapter 10 problem. Recall that the sample sizes were 53 and 65. Has there been a significant reduction in average handoff time? So I'm expecting the before to be greater than the after. So if I'm keeping it in this order, before greater than after, I have a greater than problem, even though the problem says reduction in handoff time. Okay, remember the order matters there. I could switch it and put the before first, the after first, and then that would be a less than problem. You could do that. Just make sure you switch the sign. Okay. Before should be greater than after because we're hoping time decreases. Okay, so we're talking about minutes. The mean before is 23 and the mean after is 15. So we see, 15 minutes is a lot less than 23, but we don't know if it's statistically significant yet. We're going to take into account that variability that comes from the standard deviation and the sample size. Okay, so this is the same problem. Has there been a significant reduction? So basically, if we can reject the null, then we will say yes here because we found support for the claim that the before is less than after, is greater than after. If there's a reduction, then before should be greater than after should be less than before. Okay, I have the summary input. Group 1 is the before, group 2 is the after, so that means I should have a greater than sign. The before should be greater than after. And unequal variance, 99% confidence. Okay, really, really small p-value, exponent -10, so 0.000, about 10 zeros, so close to 0. We can conclude that handoff time did go down because the before time was greater than the after time. So whenever we reject the null, we support the claim.